and that. Okay, so going back to covering what is going to be on the final. So inverse function. That's the next one up here. It looks like inverse functions. Okay. Probably, well, I would love to ask you stuff like this, but I don't really have the time. One of the things you have to check for an inverse, right? Don't forget this, is it has to pass the horizontal line test. And I think by inspection, right, this does not pass the horizontal line test. We hit 2 points in several places. So this is not a one-to-one function. Okay. All right. Let's see. However, this one is a line, so I wonder if that one is going to be one-to-one. Okay. So let's take a look at this. It's really goofy inverse functions for you guys. Okay, so we have our g of x is equal to 2 minus x over 6. Right, so this is y equals 2 minus x over 6. Okay, so our job here, right, is to find an inverse. So we're going to swap the x and the y variables. So we have x is equal to 2 minus y over 6. And the next thing we're going to do with that is we're going to go ahead and solve for y now. All right. And the same idea with the, right? PEMDAS, we're going to, instead of calculating it, doing it this way, we are going to go backwards. Okay. So this is effectively, if it's on top of the fraction like that, it's effectively a parentheses. So it's almost the last thing done. So we don't have any pluses or minuses out here, so that doesn't have to go over. So those are done. We're going to multiply by 6. Okay, so we're going to have 6x is equal to 2 minus y. Now we're up to the parentheses part, and we get to do it all over again. So back to adding. So we're going to go ahead and add y to both sides. So we have y plus 6x is equal to 2. I have a feeling they're going to want this as y equals, so let's go ahead and subtract 6x from both sides. And we're going to have, we can just do it over here. We're just going to have y is equal to negative 6x plus 2. Okay, and that's our, how many little twists do I have here? It looks like I have 1, and I don't do anything else with that, so we'll move on. Okay. All right. So on this, are we graphing? Okay, I guess we are. Okay, x squared plus 1 less than 0. Okay, so this is a little tricky to do in Connect, but it's x squared, parent function of x squared. We have plus 1 here, so we have a vertical shift of 1. Open it, place another point. So we're going to go here. All right, and then we have to snip away, right? Because we have a restricted domain, we have to cut. Oh, we have to erase part of it. I want to snip. Oh, click a point on the graph. Okay. Let's go with 0, 1. Plot point for the graph. All right. And then we're going to go ahead and erase the side of the part that we're on. Okay. And that's how you do that. So it's x less than 0. So these are the negative values. So I think we're good for that one. All right. Now, from the graph, is this a one-to-one function? Does it pass the horizontal line test? Sure does. So, yes, it passes the horizontal line test. We're good. All right. What is the domain? A lot of these are kind of redundant. So we'll hit that. So that's negative infinity. Oops, wrong one. Don't put the bracket on infinity. That's not how that works. Negative infinity up to 0. All right. Okay, write the range. The nice thing about this is that if you write the domain, that's the range of the inverse, and if you write the range, that's the domain of the inverse. So they swap places, but this is, oh, no, it isn't. It's 1 up to infinity. Write an equation, so let's go ahead and do that. Hold on. There we go. I think my friend from Scam Likely can wait. All right, so what was our equation? Our equation was x squared plus 1, wasn't it? And that was equal to my y. So to find an inverse, by the way, we know that x has to be greater than or equal to, or no, not greater than. X is going to be less than or equal to 0. And my y for the original function, right, is going to be greater than or equal to 1. Now, when I'm talking about the inverse function, my domain has to be x greater than or equal to 1, and my range is going to be y is less than or equal to 0. Okay, so that's how those work. If you ever get a tricky one of these, I recommend map out your domain and your range first, then try the trickiness of it, and then see if that helps you figure out, like, well, where does that sign have to be, or what's going on with that? Okay, so let's go ahead and subtract 1 from both sides. No, we don't. We swap the variables. That's the first thing we do. Okay, so swap. And now we're going to solve for y. Right, so that's going to be x minus 1 is equal to y squared, right? Subtracting 1 from both sides. And now we get y is equal to plus or minus square root x minus 1. Which one should we pick? Well, y has to be a negative number. So why don't we pick the one that's going to give us negative numbers, all right? So my range, my inverse function, right, is negative x minus 1. And we'll see how that goes. All right. So this is going to be negative square root x minus 1. There we go. Okay. What's the domain? Oh, no. Oh, yeah, I guess it is. No, it isn't. So let's go ahead and draw this thing. So we're going to go ahead and say, well, what's my points? Okay. So remember, y is equal to the square root, negative square root x minus 1. Let's plug in x equals 1, because the domain has got to be bigger than that. So we'll say x equals, I don't want that. Placing our first point. X is 1, y is, I think y is 0. Okay. All right. Plug any other point in. So let's plug in x equals 2. Right? 2 minus 1 is 1. Take the square root, it's 1, and then we get that negative part of it. So there we go. Right? You can see that's kind of symmetric about the line y equals x. And we don't need to do anything else. We're good. We're good at that point. There's no extra stuff we got to trim off. What's the domain and the range? Right, we've done those. X is greater than or equal to 1. Y is less than 0. So we're set. And I have a feeling the last one's going to be find the range, and we already know that. So we're going to be okay. Okay, so if you ever have a problem like this one, again, there's one in the same book, pre-calculus. There's like absolute values all over the place. Like, wow, that's kind of weird. The domain and the range are the key to solving these problems. So anytime you have one of these that is remotely tricky, go with the domain and the range and let that help you get the answer. All right. I don't think I'm going to ask you these transformations for the graph of 3x and 3x. No. I mean, I'd love to, but the book does such a good, the computer program does such a good job asking you these questions, and on paper, we do such a terrible job. I'm not going to ask you that. That's way too easy. Too easy. Okay, too easy. Better. Okay, exponential word problem. Sounds like a plan. All right. Sounds like something I could live with. All right. Okay, so let's see here. Atmospheric pressure on an object increases as the altitude increases. If A is the height in kilometers above sea level, then the pressure in millimeters of mercury is approximated by that thing. Okay. Find the atmospheric pressure at sea level. Okay, I think it should be like 7. Oh, it should be 760. Okay. You guys take chemistry, they'll do lots of stuff with this. Okay, so our pressure given kilometers, okay, was equal to 760 e to the what? E to the negative 0.13. And then we're going to just go over here and we're going to say A is kilometers and P of A is millimeters of mercury. Okay, just to keep ourselves straight, so we are going to get messed up with anything going over here. Okay, so when A is equal to 0, right, that's at sea level, we're 0 kilometers into the atmosphere. Okay, we can go ahead and calculate that. So that's going to be 760 e to the negative 0.13 times 0. Well, this is going to be 760 e to the 0, and e to the 0 is 1. So this is just going to be 760 is equal to p of 0. Okay. So we would type in 760 here. All right. Well, let me do that so people know. Sorry.
You're already off?
No, I'm on. Okay. Determine the atmospheric pressure at 5.304 kilometers. Oh, the altitude of Mount Forker. Okay, I have no idea where this is. Round to the nearest whole unit. Do not round in immediate calculations. Okay. So let's go back to here. Okay, we've got P of 5.304 is equal to 760 e to the negative 0.13 times 5.304. Okay? And that's all there is to it for that one. So 760, oops, where are we? 760 to 760 times second function inverse, okay, to the negative 0.13 times 5.304. Okay, beautiful. Okay, so about half the pressure, right? Half the pressure pretty much at sea level then. A little bit less, a little bit more rather. And what are we supposed to do? Round to the nearest whole unit. So let me double check. Yeah, it's not going to go. So that's just 381. Okay, that's a reasonable problem. And we're not going to ask you that. I could. Actually, that's not a bad problem. Would remove your dependence on a calculator, that's for sure. Okay. Although, I don't know, this seems like it would be better set with a multiple choice kind of a problem. So all they want to know is what's the equivalent exponential form, right? So the base, still the base, it's Q. Okay. And remember, the answer to a logarithm, so if they press your logarithm button, you're going to get an exponent. So Q to the S, what's left? Equal P. Okay. So that's the equivalent exponential form. So I don't know if I would ask you one quite like that, but that could be something. actually for we just did that. One of the problems I had, I gave my college algebra students a whole bunch of true and false questions to see whether or not they could do certain things. Like, I type stuff like this. Oh, a squared plus b squared equals, and then pick one. Say a plus b, absolute value of a plus b, absolute value of a plus absolute value of b. Let's see, a plus b, a minus b, and none of the above. So first off, here's the answer. Secondly, you should almost never pick none of the above because it's a sucker's choice. Okay, when you're writing a multiple choice exam, you know that the desperate student will pick this one. Okay. Now, occasionally you have to follow up and actually make that an answer. Otherwise, you don't really have 5 because the astute student will know. But yeah. But in this case, like all of these are garbage. Just this one because this can't be simplified. Okay. So I think I asked that once. Actually, more than once, but I'll do stuff like that. If you're ever confused, see, I shouldn't release this now. If you're ever wondering, right, it's more fun to lie to you with these questions than it is to tell you the truth and it gives you a right answer. So if you're looking at it like, I don't know, pick that I'm lying to you. So cannot be simplified. There's really a none of the above, but I'll write it down specifically so that there isn't another one of the above. This will be log of a plus log of b. That's garbage. Log of a times log of b, maybe. That's garbage. Log of... I have to come up with like better ones on this one. Maybe that. Okay. So this one can't be simplified. But it is fun to come up with lies. Okay, use the function file. Again, I'll do one. Okay. So use the function below to answer the following questions. We have y is equal to log base 3 of x minus 4. Use transformations of the logarithm to graph the given function. Okay, write the domain and the range. Write the equation of the asymptote. Okay, so normally with a logarithm, we would have, so if I just gave you a plain vanilla, I'm going to go with base 10 as well. Okay, log. Well, all logs have vertical asymptote at x equals 0. Okay, so if I'm going to move this thing over to the right 4 units, guess what's going to happen to my asymptote? We're going to move that over to the right 4 units. So let's go back down here. We'll say log 3 x minus 4. So here, the vertical asymptote, this is x equals 4, because that would make this thing 0. Okay. Domain and a range. Domain is x has to be greater than or just greater than, not greater than or equal to. Must be greater than 0. Y is all real numbers. Okay. Here, we moved it over. All we did, right? All we did was move it over to 4. So x has to be bigger than 4. And y is still going to be all real numbers. Okay, so in interval notation, because I don't know why our department has such an insistence on this, but they do. Because I would rather write real numbers than this. Okay. So you should have the parent function of log memorized. Okay. So log, put whatever base you'd like. This should be a function that you recognize. But you don't have to memorize every ridiculous base they come up with. Okay. Same thing with and by the way, a good one. Like if you think, oh, it's natural log. it looks like every other log anyway. If it's base 3, then this bend is going to be a little bit here. If it's base 10, the end is going to be doing that. We're not asking you for that. We just want you to know log. That would be that first one I drew. It's all logs. Okay, so that's all the one you have to know. Same with exponents. You have to know y equals b to the x. I would pick e. And boom, there. Okay. So you bet. So yeah, those are the two more functions you had to memorize for this class. So we have all the ones you came in with, and then you have these, and then when you take trig, you get 6 more. Okay, how delightful. Okay. Yes. We only really use 3, so you don't have to die too much on that one. But yeah, they're fun. Okay, so domain and arrange, we got that. Again, we're just moving it over by 4. Equation of the asymptote, x equals 4 now. So plot it. Okay. Again, we have the tooltip. So if we type in x is 5 minus 4, right? If I plug in 5 minus 4 here, that's 1, and the logarithm of 1 is always 0. Okay? Log 1 is always 0. So we have log base 3 of x minus 4. What does this look like? Right? This is my exponential form here. So my exponential form looks like 3 base to the y, right? That's my exponent, is equal to x minus 4. Okay. So we're going to pick real easy numbers here. Okay. We're going to pick y so that we have easy numbers. What about y equals 2? Okay, that's going to be 3 squared equals x minus 4. 9 is equal to x minus 4. So if we made x 13, then my y value would be, right, 2. Okay. And again, check it out, right? Put 13 in here. 13 minus 4 is 9. 3 raised to what power equals 9? 2. Okay, so we're going to go ahead and we're going to type in x is 13. Oh, we're going to have to say plot point. X is 13 and y is 2. All right. And I'm just going to plot this point of 4, 0. That's going to help me with my asymptote. So we'll see. We might be erasing that point, but there we are. So place the vertical asymptote. It'll snap to it. Okay. First point, second point, done. All right. So if they ever give you one that's a little bit hard to get, plot it with the tool first, then you can go through and deal with everything else. They're not telling me whether or not I'm correct. They're being sneaky here. Be rate the domain and arrange. We kind of did that, right? We kind of did the domain and arrange. So right here, 4 to infinity, and then y is all of them. Okay. So this is 4 off to infinity. Range is going to be negative all the numbers. Okay, that's all they really wanted, I think. Vertical asymptote, y equals 4. Why? He told me to do it up there. Who knows? All right. Let's see here. No. No, we're not doing this. It's nice to know, but no, we're not doing that. Oh, do you guys have one that's just a little bit harder? No, they don't. Okay, it's final exam. Don't go nuts, right? Keep it simple. So here's the basic idea. We have 11 to the r plus 6 is equal to 871. Okay, we're going to solve for r. All right, so I'll remind myself. We'll say exponentials equation, solve one variable in exponent position. All right. The pre-calc class, they have them in both positions. You got to do all sorts of shuffling. All right. Subtract 6 from both sides because we want to make this a clean logarithm. Okay, so we have 11 to the r is equal to, God, this is embarrassing, 871 minus 6, should be like 865, okay. Now, I don't care what this number is, I don't care what that number is. We're taking logarithms of both sides. I recommend either LOG or LN. Okay, don't try to get fancy with like, hey, I'm going to take log base 11 of each side. Like, you can, it's not going to, it's not wrong, but you're being a little too fancy for what this really is. So let's go ahead and take that log because most people like log base 10. 11 to the r is equal to log 865. I think it's important to remember, right? If you're going to do log, it's got to be log of something. Okay, don't just put a log out in the middle of nowhere. It's just like, well, it's 5 times log. It's 5 times the square root. I mean, that doesn't make any sense. Don't do that. Okay, so always give your logarithm an argument, always. Okay. So we're going to use our rules of logarithms. That's going to come down in front. So we have r times log 11 is equal to log of 685. That's a number. Okay, that's a number. So we're just going to say r is equal to log of 865 divided by log 11. Okay, and our change of base formula, if you wanted to really do that, don't. But log of base A, this is equal to log, pick a common base, divided by log base C of B. So if you pick log base 11, this is what you'd end up with when you wanted to figure it out numerically. But that's kind of like a classic. Everybody who graduates from college algebra should be able to solve this problem. Okay, so I would count on one like that. That's definitely up there. Okay. And I'm not going to ask you. I'm not going to say get your calculators out and approximate. I'm just going to say what's the solution. Okay, it's an exponential function. You don't have to check it. You have to check logarithmics, but you don't have to check the other ones. Do we have one that's a little bit harder? No. This is fine. Let's go ahead and give us a, okay, so this is 11. This is a logarithmic equation. Okay. So there we are. These, by the way, you have to check. So here we have log 4 log 5p minus 3 minus 2 is equal to 10. And again, right, we've got an equation to solve. We've got exponent, that's a logarithm. So we're going to go this way. Let's take care of the arithmetic. Add 2 to both sides. So we have 4 log 3, 5p minus 3 is equal to 12. Okay. Moving up the hierarchy here. Now we have to deal with multiplication and division. Let's go ahead and multiply both sides by a quarter. Okay. So here we have log base 3, 5p minus 3 is equal to 3. This is really what I want before I'm going to deal with the logarithm. It's something that's clean. I don't want weird stuff over here. But what we're going to do is we're going to make the logarithm the exponent on both sides. Okay, we're going to make whatever this is the exponent. So we have 3 log base 3, 5p minus 3 is equal to 3/3. Be careful at this point. For all the students that get to this point, 3 cubed is not 9. It's 27. Okay, that is one of, okay, other than some of the really terrible errors you can make over here, like distributing, this is the problem. This is probably, for the people who get to this spot, this is the most common error, is not being able to calculate this correctly. Okay, because you're in a hurry, I get it. Oops, no more logarithms, those are gone. Oops, I don't want to do that. Cancel. Okay, so let's get rid of that. Put this back in. 5p minus 3. Okay, add 3 to both sides, add 3 to both sides. Right, we have 5p is equal to 30, p is equal to 6. But don't answer yet, there's more. If I take my 6 and I plug it back into the original problem, 5 times 6 minus 3. Right? 5 times 6 minus 3. Is this going to give me a positive number? Right, we're going to get 30 minus 3, it's 27. Yeah, I'm pretty happy with that. So I checked it. So we're good. If you don't check it, if you don't let me know you checked it, it's automatically you're losing a grade for that one. I mean, I'm not a whole final, but this problem, right? If you got everything right and you didn't check it, you're getting a 5 out of 6. Okay, so it's automatically a 1 grade deduction on that one. If you give up and you can't answer it at all, I don't like give you a minus F for it or something, but you know, but realize that if you're doing this, you still have one last thing to do. Okay, so in this case, the solution set, what did we say? That was 6. I mean, again, not that it really matters. They're not going to check me, so thanks. Okay. Not a big fan of this problem. I like word problems, but I don't know. I'm not really into that one. This one, there's a harder version of this one. My pre-calc class really, they had a tough time with this one. Oh, this is even nicer. Oh, good Lord. No, it's too easy. Let me show you. All they're going to say is like P of t, right? We're going to do t years after 1,000, or 2,000 rather. So P of t is equal to, oh, maybe it's not. Because they want to know what k is. Maybe this isn't as easy as I thought. So we're going to say we've got 66 is equal to 50 P E to the k. I don't know what the population growth is, but I do know 10 years have elapsed. All right. So we're going to do 66 over 50 is equal to, right, dividing. Oh, I don't need that p. You know why? Because 50 was my p. E to the 10k. Solving for k now. I'll say, hey, we've got a variable in the exponent position. What do we do about that? Take a logarithm. Because that allows us to pull this down in front. So we have 10k times natural log of e. You know what the natural log of e is? It's 1. Right? And then we're just going to divide both sides by 10, or multiply by a 10th. And how many decimal places? 5 decimal places. Very good. So we're going to say 0.1, that's 1/10, right? 0.1 times ln 66 divided by 50. So 0.02776. 1, 2, 3, 4, 5. 0.02776. Okay. You can plug this back in if you wanted to, make sure it got the same thing. This was 50 e to the, what did we say that answer was? 0.02776. 0.02776 t. Okay. You can do the same thing for turkey. Oh, we're going to have a next part. This is going to be wrong. Okay. This is 67.4 e. I'm just going to say to the t. Okay, since they're not going to grade me, that's fine. But we go through and do exactly the same process. All right. Using the models, approximate the population on January 20th, or January 1st, 2020. This is really the formula people use for population. Actually, it's not. It's a little bit harder. The one we really use is a little bit more difficult. But for a lot of places, this is a perfectly good approximation for population. Okay, the UN will use something like this. The Census Bureau will use something like this. This is really used. So you should get an answer that seems reasonable. Okay, so if we know that that's our model, right? We know that this was P of t is equal to 50 e to the 0.02776 t. We should be able to get a decent amount, a decent approximation for the people, for the population there. All right. I really want to just reiterate that this is actually used because, again, I've seen students they'll forget one of the zeros and they'll just put 2.776 or something. And then I've got 6 billion people in the Congo. And I don't think it's going to support that much. Okay, so look at it as reasonable, as actual, you should be getting realistic numbers. P of t is equal to 50 e 0.02776 times 10. Oh, sorry, times 20, because we're 20 years in the future here. This was taken. I said I get people that like, there'll be 7 million people in Scandinavia after the end of 20 years. Like, these are people, not rabbits. Okay. There we go. Okay. So we're going to have, it's going to go from 50 million to 80 million, 87 million. So I hope they're building some roads, because that's only 20 years. Okay, you haven't quite doubled your population there, but you're going to need some water treatment plants. You're going to need some roads. You're going to need a place to put your garbage, all that stuff. Okay. So there we go with that. So what else they have here? I'm going to pick one of these. My more favorite problems. Okay, so let's go ahead and put this one on here. Perfect. We need exponential word problem. Perfect. Okay, that's 12 problems. That's great. You guys will have the luxury of, we'll say 3 index cards. I know I didn't do a third test, but I don't think it's right at this point for me to give you guys a third test, and I know I'm not going to grade them in time, so we're not going to do one unless you guys really want one. But yeah, you guys can have the 3 index cards, 3x5 cards when you're doing these. Okay. I would recommend that if you're putting more than two example problems down, to not do that, because it's going to take you a long time to go through your cards, and it's not good. It's not good at all. All right. I had a student years and years. This is what I stopped giving index cards after I had the student. She had an A. I mean, she had an A. I mean, she had crushed the entire class. And she got to the final, and I was like, "You guys can have an 8.5 by 11 piece of paper. My eyes suck, so it's okay." And she came in with that 8.5 by 11 piece of paper, and it was covered, absolutely covered with formulas and everything else. I mean, you needed like one of those jeweler eyepieces to see what the heck was going on with that. She shrunk the font down and everything. There was so much written on that. And I mean, like an hour had passed, and I was like, "Okay, you guys are down an hour. Make sure you're about halfway through your exam." And she just kept working. I mean, all she needed to do was come in with a pulse, and she would have gotten an A. And I was like, 2 hours goes by, and I'm like, "Okay, you guys are getting done, right?" So like, I need a little bit more. Okay. And after 2.5 hours, she had answered one question because she couldn't match it. And that was a disaster. I told her to come back the next day. I was like, "We're not doing this. So come back tomorrow. We'll take it again. Do not bring any formulas with you." And she did. She did great. I was like, "Why did you?" And she got nervous. I'm like, "Okay, I get it." Okay. So here, half-life is 87.7 years. Okay, we start with 3.5 kilograms. You don't have to start with 3.5 kilograms if you don't want, but we will. So I'll say half, right, of 3.5 is equal to 3.5 E, because that's my Q0. I don't know what K is, because that's our rate, and then here's 87.7 years. Okay, I'm going to cheat, and I'm going to divide both sides by 3.5 before I do this. So what's going to happen to my 3.5s? They're gone. So I have 1/2 is equal to E 87.7 K. All right. So if you do have to write a problem down, I mean, I get it. I had to do that. But if you have to write more than like 2 or 3 problems down, you need to study more. All right. Natural log of both sides. Why? Because we have a variable in the exponent position. Pull this down. So we have natural log of 1/2 is equal to 87.7. Natural log of E, which you know is 1. Oops, there's a K here. Okay. And then divide 87.7, divide 87.7. So K is equal to natural log of 1/2 divided by 87.7. Let's plug that in the calculator and see what we get. Okay, so here we go. Natural log 0.5. That's what turned on. Natural log 0.5, that's 1/2 divided by 87.7. Just 1 7, everybody. All right. K is equal to 0.0079 negative. Okay. So we launched it in 2012 rather. What did we say this was? Negative 0.0079. Next part. We need 1.7 kilograms. Really? I would probably put something like 2 because I don't want it too close to a half-life. We need 1.7 kilograms to power the spacecraft. How long does this thing retrieve data for us? Okay. This one. So let's go with 1 point. Well, let's write the formula down. Q is equal to Q sub 0 e to the kt. Okay, so this is 1.7, 3.5 e to the negative 0.0079 times t. We are solving for t. So 1.7 divided by 3.5. Here's why I probably wouldn't write the formula just like this, because 1.7 divided by 3.5 is almost a half. So if you just count down by half-lives and give me that answer, it's going to be real close. I'm not going to let you do that. Okay, I'm going to probably pick 2 here, right? Or maybe 1, but something you can't do with half-lives like this for. Okay, so that is, so we have, we're going to solve for t, so we need to take logarithms of both sides. All right, this bit here, the whole reason it took a logarithm was to be able to put this down on the baseline. And then we're going to divide by that out there. So we're going to have natural log of 1.7 over 3.5, all divided by negative 0.0079, and that is equal to t. Okay. So let's see here. We're going to have natural log. We have to take the log of this, right? So ln of that previous answer. That's how you do that. And then divided by negative, well, it doesn't have to be negative. 0.0079. Okay, the negatives are going to cancel, so we just know that the time will be 91.4 years. Right. I have a number of these problems. Right. So realize like it may not be precisely the same story, but it'll be a very similar kind of a problem. Okay. So yeah, that looks like a pretty good final. I like it. Okay. So give myself a little note here. Oh, what can you do? You can have three index cards. You can put 4 problems or four notes on each one. You won't need that much. You really won't. Okay. Like I might write down the equation of a circle, the general one, just to make sure. Write down slope, point slope form. Okay. Difference quotient. I'm going to hand you the difference quotient when you do it, so you don't need to write that down. Yeah, I think we're good. That's it. I'm going to write this up in both ways, and I'll post a pre-one. I'll post a pre-final, so we can narrow down on these, so you don't have to go through the entire pre-final thing, because that's a lot of questions. It's too much. And then I'll post that, and I'll post this one to go along right on the side of it. Okay. So I'm going to go ahead and probably stop doing all of that. So I'm going to stop recording. That's what I'm going to do.